First formula is Q is equal to Ne. The total charge flowing, that is number of electrons into charge on one electron. N here is Q is total charge. I is equal to Q by T. Ne by T, units ampere or coulomb per second. Am I right? Third formula. V is equal to W by Q. What is that? The potential difference between any 2 points in a given circuit is the work done in moving a unit charge from one point to the other point. Suppose this is the electric circuit. Positive, negative. This is the resistance R. I want to find potential difference across this. Okay. So it is the work done in moving unit charge Q from this point to this point. So that will be the potential difference. Its unit work like energy. So units will be joule per coulomb. Charge unit is coulomb. This is called volt in honor of scientist Alessandro Volta. Okay, who gave this? So work is done in moving unit charge between 2 points in the given circuit. So that will give you the potential difference between those 2 points. Understood? That is V. Fourth formula, Ohm's law. V is equal to IR. I here is the current flowing in the circuit. R is the resistance of the circuit. Yeah. So actual, it is V directly proportional to I. More the potential of the battery connected in the circuit, more current will flow for a given circuit. Okay. Any other parameter is not changed. When you remove this proportionality sign, you will get a constant which is nothing but the resistance of the circuit. V is equal to IR. Got it? R here is resistance of the circuit. It is depending upon these factors. The formula for R, next formula, rho L by A. Here, L is length of the conductor. A is area of cross section of the wire. And rho is resistivity of the material of the wire. Got it? It is depending upon the nature. L and A you can change, but rho is depending upon nature of material which you use to prepare the resistance wire. Next formula, the heating effect of electric current, right? The heat produced, yeah, H is directly proportional to I square. H is directly proportional to the resistance of the circuit, and H is directly proportional to the time, okay, the time through which the current is flowing in the circuit. Okay, so when you remove the proportionality sign, you will get a constant K I square RT. Constant is chosen having magnitude 1. So you can say H is equal to I square RT. Now, I is equal to V by R. I can substitute that value here. I will be getting V square by R square into RT. 1 R will get cut. You will get V square by R into T. Am I right? Another formula for heat. H is equal to V square by R into T. Right? Another formula, one more is there. R is equal to V by I. So H is equal to I square into V by I into T. 1 I will get cancelled. So H is equal to VIT. There are three formulas for the heat produced in a given circuit. Got it, beta? So total three formulas for the heat generated. Now this heating effect is shown by specific elements. Tungsten, it has high resistivity. So those materials which offer high resistivity or which have high resistivity, in those materials, most of the electrical energy is converted into heat energy. And we use tungsten as filament in the electric bulb. Reason? It has high melting point. It converts most of the electrical energy into heat energy, and it emits light at high temperature, and it doesn't melt easily. So that is the reason why tungsten is used in heating appliances. Okay. Then you have, I think, commercial unit of energy. What is that? Kilowatt. Commercial unit of energy. It's kilowatt hour. Are you getting? When? Why? Because power is energy consumption, rate of energy consumption. Energy by time. When you use word rate, that means with respect to time, how much energy is getting consumed or how much energy is getting produced. Power is energy by time. Energy is equal to power into time. Now, unit of power is watt. Unit of time is second, SI unit if you take. So this is called joule. So 1 joule is equal to 1 watt into 1 second. Did you get it? If I take bigger units of power, kilowatt, and time unit if I take in hour. So that is kilowatt hour. Did you get it? Now 1 kilowatt is equal to 1000 watt into 1 hour 3600 seconds. Now watt second is joules. So when you write this and this in scientific notation, 3.6 into 10 raised to the power 6 watt second, and 1 watt second is equal to 1 joule. So 1 kilowatt hour is equal to 3.6 into 10 raised to the power 6 joules. Is it clear, people? Yes? These are the formulas for electricity chapter. You got it? Now, important questions based on this. First type of questions are like a wire of length L and cross section area A is stretched in such a way that its new length after stretching becomes 3 times the original length. Okay, if initial resistance was 3 ohm, calculate new resistance after stretching. Okay, how would you solve this? Here, initial length L1 is L, A1 is A. Please remember, if you are not adding any matter to the existing matter, its volume remains same, whatever shape it acquires, its volume remains same. So L2 is 3L given in the question. A2 we do not know. Okay, so the concept here is volume remains same. That means L1A1 is equal to L2A2. So L1 is L into A is equal to 3L into A2. So this and this will get cut. A2 is equal to A by 3. You got it? Now, new resistance R2. R1 is given to you. R1 rho L by A. R2. Rho is not changing because you are not changing the material. Same wire is stretched. Rho L2 by A2. So rho into 3L. A2 is A by 3. So you are getting 9 times rho L by A. And rho L by A as per the question is equal to 3 ohm. So 9 into 3, 27 ohm. Is it clear? Yes, people? Next,
Yes, ma'am.
if they ask you a wire of length L and cross section area A is doubled on itself. Are you getting? That means it's folded. It's like this. Previously it was like this, and now I have made it like this. So length has become, this is L, this is L by 2. You got it? If initial resistance was you take 4 ohm, find the new resistance, right? So same thing here, R is equal to rho L by A and R dash rho L dash by A dash. Here area will change. Please remember, I told you initially L into A is equal to L dash into A dash. Got it? So L into A, L dash is L by 2 into A dash. This and this will get cut. A dash is equal to 2A. You got it? So here area has become 2A. because volume remains same as I told you. Now R dash rho, L dash is L by 2, area is 2A. So A dash is 2A, so it is becoming 1 by 4 rho L by A. And rho L by A is given in the question 4 ohm, initial resistance. Hence, R dash 1 by 4 into 4, 1 ohm.